we focused all our attention on a single moment, 4 billion years in the future, the epic collision of the Milky Way and Andromeda. But we were looking so far away that we missed the greatest truth. That collision has already begun. Yes, you heard that right. Webb and Hubble data have proven that our invisible galactic halos, each 1 million light-years wide, are intermingling right now. This silent embrace has been going on for 1 billion years, but that's not the whole story. Our neighbor's 140 million solar mass heart is unexpectedly waking up. It's blasting out X-rays 100 times more powerful than normal. This means the predator is waking up, just as it enters our territory. If you want to understand this cosmic event that you are living inside of right now, hit the subscribe button, because Logiat, the timeline you know for the end of our galaxy, has just completely changed. Here we go. For years, we thought of Andromeda as a quiet neighbor. We saw that hazy faint smudge in the sky as a peaceful island of stars. We mapped its beauty. We thought it was just sitting there quietly, about 2.5 million light-years away. But then the James Webb Space Telescope turned its golden mirrors towards it, and everything we thought we knew changed. Because Webb showed us that the universe is not just made of the colors we can see. The real stories were hidden in the darkness, beyond our sight. We now understand that quiet neighbor was actually a predator, coming towards us for billions of years. To understand this truth, you must first grasp Webb's superpower. How small a fraction of reality do our eyes show us? The rainbow of colors we see. The visible spectrum is just a thin slice of the electromagnetic radiation. But beyond violet, just lie ultraviolet, X-rays, just and gamma rays. And beyond red, there are infrared, microwaves, DADs, and radio waves. A huge part of the universe whispers in frequencies we can never see. This is where the James Webb Space Telescope comes in. Launched in December 2021. Webb does not see the universe like we do, because its sensitive instruments are tuned to the infrared wavelengths, the thermal signature of the cosmos. This gives it a power Hubble never had, the ability to see through cosmic dust that completely hides visible light. Think about it for a moment. Try to see through a dense fog with your own eyes. It's impossible. But now, imagine you have thermal vision goggles that detect heat. The fog suddenly becomes transparent. This is exactly what Webb does when it looks at galaxies like Andromeda. And when it pointed its massive 6.5-meter mirror at Andromeda, it saw structures that had been hidden from us for billions of years. Those dust bands that looked dark and empty in visible light suddenly glowed with an infrared energy under Webb's gaze. This is how we understood. Those bands were not empty. On the contrary, they were filled with cool stars, molecular clouds, and organic compounds, all the raw materials needed to build new solar systems, star-shaped nurseries. Thanks to Webb, we now know the secrets of galaxies are not hidden in their bright lights, but in the whispers of their heat. But this new vision also revealed a staggering scale. The size of the Andromeda galaxy pushes the limits of our minds. It contains 1 trillion stars. Let's pause and consider that number for a moment. If you counted 1 star every second, without ever sleeping or stopping, it would take you 31,700 years to count them all. That's the number of stars shining in Andromeda right now, each one a nuclear furnace in its own right. Most are smaller and cooler than our sun. Some are massive blue giants that will explode as supernovae in a few million years, and all of them orbit a common center of gravity, held together by the invisible hand of dark matter, which is 6 times more massive than the stars themselves. This galaxy has a diameter of 220,000 light-years, almost twice as large as our own Milky Way galaxy, and its total mass is mind-boggling. If we count both its stars and the dark matter halo surrounding them, Andromeda contains about 1.5 trillion times the mass of our Sun. In contrast, the Milky Way holds only about 800 billion solar masses. This means Andromeda is almost twice as heavy as our galaxy. This size difference is critical for our future, because when 2 galaxies collide, the larger one usually wins. And in about 4 billion years, when these 2 cosmic giants finally meet, Andromeda will be the bigger, more predatory partner in this encounter. But the most disturbing feature of our massive neighbor is not just its size, it's also its past. Because galaxies are not static. Peaceful places, they are billion-year-old battlegrounds, where gravity is the absolute ruler. In these arenas, the strong consume the weak, and the large devour the small. And Andromeda is no exception. It's a cannibal that has been feeding on its neighbors for billions of years. The proof is etched into the stars themselves. When we study Andromeda's star populations, we discover something remarkable. The faint, old cloud of stars surrounding the galaxy's main disk, the outer halo, contains distinct streams of stars moving in organized patterns. These streams are not random, because they are the shredded remnants of smaller galaxies that Andromeda has captured, torn apart, and destroyed. When a dwarf galaxy falls into the gravitational well of a giant like Andromeda, tidal forces stretch it out into a long ribbon. Over millions of years, these stars are stripped away one by one and spread out like a river along its orbital path. Eventually, the dwarf galaxy is completely destroyed, but the stream it creates can persist for billions of years, a ghostly sign of what once was. Using the Hubble Space Telescope, we have mapped dozens of these stellar streams in Andromeda's halo. We now understand that Andromeda has devoured at least 100 to 200 smaller galaxies in the last 12 billion years. One of the most significant mergers happened just a few billion years ago. This collision brought a huge but when we put all these pieces together, the picture becomes even stranger. Because Webb's data showed that this history of cannibalism was feeding the monster at the center. But this monster wasn't just feeding, it was also waking up. And the first signs of this awakening appeared in Andromeda's heart, in a place no one expected. With a strange anomaly, an illusion that looked like a double nucleus, and the terrifying truth behind this illusion. And this terrifying truth first revealed itself in a mystery captured by the Hubble Space Telescope in 1991. When astronomers looked at the center of Andromeda, they saw not one bright nucleus, but two separate concentrations of light, just 5 light-years apart. For years, this double nucleus sparked heated debates because the most popular theory suggested that Andromeda had recently cannibalized a smaller galaxy, and the brighter spot, called P1, was the leftover nucleus of that victim galaxy. It was a dramatic explanation that fit the evidence of large galaxies growing by eating smaller ones. But there was a problem with this theory. If P1 were a captured galactic nucleus, it couldn't be stable. The tidal forces from Andromeda's main black hole would have torn it apart in just a few million years. Yet how P1 appeared solid and orderly, the timeline didn't add up. So, observations with more advanced instruments revealed the truth. The fainter spot, but known as P2, was the actual location of the supermassive black hole. P1 was not a captured galaxy, it was an illusion. Created by an eccentric disk of stars orbiting the black hole. The stars in this disk weren't moving in perfect circles. Their orbits were stretched into long ellipses. So, as they orbited the black hole, they slowed down and bunched together at their farthest point from the center, just like cars slowing down and clustering as they enter a sharp turn on a racetrack. This clustering made us see a second bright nucleus for a moment. It was a more elegant explanation, but it raised a much more disturbing question. What could have pushed the stars into such bizarre orbits? The answer was hidden in another act of violence in Andromeda's past, a black hole merger. Because when two supermassive black holes spiral towards each other and finally collide, they emit gravitational waves. If the masses or spins of the black holes are different, these waves can give the resulting new black hole a powerful kick. This kick can disrupt the orbits of nearby stars, flinging them into the exact kind of chaotic, eccentric orbits we see. Computer simulations support this idea. So, we know that the monster at the center of Andromeda is itself the product of a collision. It likely turned into the monster it is today by merging two smaller black holes, each with tens of millions of solar masses. And the scale of this monster eclipses everything. Its mass is estimated to be 140 million times that of our Sun. Let's pause for a moment to understand how monstrous this figure is. The black hole at the center of our own galaxy, Sagittarius AA, has a mass of about 4 million suns. Andromeda's black hole is 35 times larger, the point of no return around a black hole. The event horizon expands with its mass. For Sagittarius, or our, the radius of the event horizon is about 12 million kilometers, but the event horizon of Andromeda's black hole has a diameter of about 400 million kilometers. That is a sphere of doom, larger than the orbit of Mars. Anything that crosses this boundary is lost forever. But what's truly frightening is that this giant is not dormant. For a long time, we thought it was. Because black holes don't sleep in the way we understand it, but they can be quiet or loud depending on how much matter they consume. When a black hole greedily devours the gas and stars around it, it becomes one of the brightest objects in the universe. This is called an active galactic nucleus, and it can outshine its entire host galaxy. Andromeda's black hole was not like that. It had been classified as dormant for millions of years. It was just there, occasionally swallowing a stray gas cloud. But then came the X-ray observations that changed everything. The Chandra X-ray Observatory had been monitoring Andromeda's core since the year 2000. For over 15 years, it recorded a steady but faint X-ray signal from the central black hole. But in 2006, Chandra detected an unusually powerful flare. The X-ray brightness increased 100-fold. Then it faded again. The event was noted as interesting. But in 2013, it happened again. Another powerful flare. And this time, there was something strange alongside it. The Ice Cube Neutrino Observatory in Antarctica detected a flood of neutrinos. Coming from the exact direction of Andromeda. Neutrinos are ghost particles that almost never interact with matter. Their presence indicates they are produced in the most extreme environments, where matter is being torn apart by unimaginable forces. This couldn't be a coincidence. The latest analysis, OLT, published in 2025, confirmed the suspicions. The black hole had remained in a high-activity state since 2006. Its baseline X-ray emission was higher than before. The flares were occurring more frequently. This was data. This was a fact. The monster was waking up. This is why James Webb's gaze upon Andromeda was so frightening. When all these concepts came together, what do we have? A super telescope that sees through dust with its infrared vision. A monster with 1 trillion stars and 1.5 trillion solar masses. Twice the size of our own galaxy. A history of a cannibal that has devoured at least 100 galaxies. Strange star orbits at its center. Evidence of a past black hole merger. And at the heart of it all, a giant black hole of 140 million solar masses. Moreover, we now know that this black hole has been waking up since 2006. So, what new and disturbing evidence did Webb's infrared eyes find about this awakening? What do we see when we set aside the theories and look at the actual data the telescope sent us? What they saw proved that the chaos at the center was only the beginning. Because, Hawasi, gas clouds were moving much faster than they should have been. And no one knew. Why? And now comes the real shock. The theories were thrown aside. The models fell short. Because the data Webb sent back was not just an anomaly, it was proof. Proof that something was going horribly wrong in the heart of Andromeda. At the very edge of the physics we know. Get ready. Because here are the real findings. The first shock came from the dust rings around the center. They shouldn't have been there. At least, not like this. When scientists focused Webb on Andromeda's core, they expected to see dust rings glowing with bright infrared light. But that's not what they saw. The rings weren't smooth and uniform. There were gaps, distortions, clumps. It was as if someone had come in and stirred up the matter at the galaxy's center in the last few million years. That's like yesterday on a cosmic timescale. We couldn't explain the temperature variations within these rings. Regions that should have been cooling down were heating up for an unknown reason. But the real shock came when Webb analyzed the chemical signatures. Inside this dust, it found complex carbon molecules, organic compounds, that previous telescopes had completely missed. The basic building blocks of life. Forged in the hearts of dying stars and then scattered into the galaxy. This was like a fingerprint at a crime scene. A recent violent event had disrupted these rings. It had misshapen them. According to our models, these rings should have smoothed out and settled over billions of years under the immense gravity of the central black hole. But they were distorted, broken. So, we realized the heart of Andromeda was not calm. On the contrary, it had recently undergone a massive upheaval, but this was only the beginning. Webb looked deeper, and it found the hidden nurseries. This discovery was even more impossible. We knew that Andromeda's star formation rate was slowing down, while our own Milky Way galaxy produces about 7 new stars each year. Andromeda was producing maybe only 2 or 3, because a giant merger in its past had consumed most of its gas reserves. Without raw material, new stars couldn't be born. The galaxy was slowly dying. But Webb shattered this general consensus. It looked deep inside the thick dust cocoons in the galaxy's spiral arms. where visible light telescopes could never penetrate. And there, it discovered regions producing stars at an incredibly high rate. In these hidden pockets, the star birth rate was tens of times higher than the overall average, far beyond expectations. Newborn stars are hot. They bombard their surroundings with ultraviolet radiation. This radiation heats up nearby dust, causing it to glow in infrared wavelengths. Webb can calculate how many young stars must be there by measuring this glow, and the numbers were much higher than the models predicted. This should not have happened. How could parts of a gas-poor, such an aging galaxy suddenly become so active? One theory points to gravitational interactions with dwarf galaxies, but the interaction needed to explain such intense activity would have to be much more than a simple graze. Andromeda was dying, but parts of it were burning brightly, as if someone had poured gasoline on a fire. And then came the most terrifying discovery: the gas flowing into the center. It wasn't just flowing, it was accelerating, uncontrollably. Webb saw thin filaments of gas and dust spiraling toward the black hole. That was expected, but the speed of some of these filaments was not. Gas accelerates as it approaches a black hole. That's normal, but the speeds we measured were much higher than gravity alone should have created. Something was pushing this gas. There was an extra force, just a few light years from the black hole. This orderly spiral became chaotic. It was transforming into turbulent eddies and swirls. This was the accretion zone, where matter reaches a significant fraction of the speed of light, is heated to extreme temperatures, and is torn apart by tidal forces. But the filaments further out told the story clearly. The monster at the center was feeding, and the matter feeding it was being accelerated by an unknown force. This defied the laws of gravity. Gravity, the force physicists understand best, could not explain this speed alone. Perhaps magnetic fields were channeling the gas along certain paths, or perhaps jets erupting from the black hole itself were creating a pressure that pushed nearby gas. In either case, yes, this was not a simple feeding process. It was a violent, chaotic event that did not follow the known rules. Distorted rings, unexpected star nurseries, and gas speeds that defied gravity. These three discoveries found by Webb were not independent anomalies. They all pointed to the same terrifying truth. The massive black hole at the center is not just waking up. It is also reshaping the entire galaxy around it. And it is doing so by rules we do not understand. But what exactly triggered this process? What was the first domino to fall that started this chaos? As scientists tried to piece these parts together, they realized the most important piece of the puzzle was the galaxy's oldest inhabitants. And these inhabitants gave us the clearest evidence of cannibalism. They were Andromeda's tombstones, the globular clusters. And the story these clusters told was much more complex. And this complex story revealed Andromeda's most astonishing secret: ghost galaxies. Globular clusters are dense balls of hundreds of thousands, even millions of old stars, tightly bound by gravity. Andromeda has more than 400 globular clusters. Our galaxy has only 150. This difference itself is proof that Andromeda has a much more violent past, because these clusters are the spoils of war, left over from devoured galaxies. Webb's sharp infrared eyes were able to penetrate even the densest centers of these clusters, and it read the chemical fingerprint of each star. And what it found was a complete shock. The globular clusters were divided into two distinct populations. One group rotated in the same direction as the galaxy's main disk. These were likely Andromeda's native clusters. But the other group was moving in wildly tilted orbits, some even in the opposite direction. These were the invaders. They had been captured. But the real bombshell was this. These invaders were also divided into two groups. One subgroup appeared to be the remnants of a merger that occurred about 2 billion years ago. The other was much older. It dated back to about 10 billion years ago. Two separate acts of cannibalism. Each had left a different signature in the halo. This was galactic archaeology, and this archaeology told us that Andromeda was constantly feeding, constantly growing. But even this discovery could not explain the biggest anomaly. The Great Plain of Andromeda. This structure should not exist according to current cosmological models. It seemed completely impossible. Andromeda has at least 14 confirmed satellite galaxies. These small galaxies orbit the giant, but this was no coincidence. Most of the satellites were not orbiting randomly. They were moving in a surprisingly thin and coherent plane, all in almost the same direction. This was an organized structure, almost impossible to form by chance. It was as if an invisible hand had strung these dwarf galaxies together like a string of pearls. This structure challenges our current understanding of dark matter, which we thought was the skeleton of the universe. Because dark matter models predict that satellite galaxies should have a random, spherical distribution around the main galaxy. But that's not what we saw in Andromeda. This plane was there. The data was conclusive. One theory suggests that these satellites are the leftovers from Andromeda's disruption of a much larger structure. Perhaps another galaxy group. Another, even more provocative theory claims that the gravitational pull exerted by our own galaxy, the Milky Way, millions of light years away, is stretching Andromeda's satellite system and forcing these satellites into specific orbits. If this is true, the interaction between the two galaxies began much earlier and in a much more complex way than we thought. And now, the ultimate truth that brings all these discoveries together, the most shocking of all. Our collision with Andromeda is not a distant future event that will happen in 4 billion years. The process has already begun. In 2020, scientists mapping the vast gas cloud surrounding Andromeda, its halo, found something unexpected. The halo was much larger than previously thought. This massive hot ionized gas envelope of Andromeda extends for about 1.3 million light-years in every direction from the center. The Milky Way has a similar halo, and recent measurements have shown that our halo is about the same size. This is where the problem begins. Andromeda is only 2.5 million light-years away from us. If both galaxies have halos extending 1.3 million light-years in every direction, it means they are already touching. In fact, they have probably been in contact for more than 1 billion years. This is a confirmed observational fact. The collision between the Milky Way and Andromeda has already begun. Right now, as Andromeda's halo passes through ours is passing through Andromeda's. The interaction is so faint that we don't notice it, because the gas in the halos is incredibly sparse. But the consequences are profound. These two cosmic islands are no longer separate entities moving through space. They are in an inevitable dance that will end in a merger. Distorted dust rings, hidden star nurseries, accelerating gas streams, the ghosts of two different cannibalistic eras, and a satellite galaxy plane that shouldn't exist. Finally, a collision that has already started. When all these discoveries come together, the picture that emerges is not of a quiet neighbor, but of an active, much chaotic giant whose rules we do not yet understand. Webb showed us not only what is happening, but also how little we know. So, how does this incredible telescope do all this? How do its eyes work? What tools does it use to reveal the anatomy of a galaxy in such detail? It's time to pull back the curtain on the technical secrets of this complex machine. Because, to understand the secrets of the monster, we must first understand how the eyes that see it work. And the technology behind these eyes is as complex. But how does this incredible telescope do all of this? It's time to leave the shock of the discoveries behind for a moment and look under the hood. Because behind the revolutionary data Webb sends us lies decades of engineering, unimaginable precision, and technologies that push the boundaries of physics. We are now moving from fast-paced discoveries to a calmer, deeper analysis. We will try to understand the mechanisms behind those golden mirrors and complex instruments. Because, to solve the secrets of the monster, we must first understand how the eyes that see it work. Webb's first and most fundamental power is looking into the infrared universe. To understand this, consider a simple metaphor. Imagine trying to see through a dense fog with your eyes. It's impossible, because the fog scatters and blocks visible light waves. But now, imagine you're wearing special thermal vision goggles that detect heat. The fog suddenly becomes almost transparent, because thermal goggles see heat, or infrared radiation, which has longer wavelengths. This is exactly what Webb does when it looks at galaxies like Andromeda. Cosmic dust clouds are like a dense fog surrounding young stars and galactic centers. For telescopes like Hubble, TOL, which work mainly in visible light, this dust is an impenetrable wall. The wavelength of visible light is quite short, between about 400 and 700 nanometers. And these short waves get stuck and scattered by dust particles. But Webb detects much longer infrared wavelengths, starting from 0.6 micrometers, 600 nanometers, and extending to 28.5 micrometers. These long waves pass through the dust particles like a ghost. That is why Webb can see places Hubble could never see, like the star nurseries hidden behind dust, galactic cores, and cold gas clouds. This isn't just seeing better, it's seeing a completely different universe. While Hubble shows us the bright, shiny facades of galaxies, Webb shows us their skeletons, their veins, and their hidden organs. This ability is the fundamental mechanism that allowed us to discover Andromeda's unexpected star nurseries and distorted dust rings. Because the secrets were hidden not in the light, but in the heat. But Webb has not just one, but two different eyes. This is its second great secret. This massive telescope combines two different cameras to reveal Andromeda's hidden anatomy: the near-infrared camera, NIRCam, and the mid-infrared instrument, EMIRI. You can think of these two instruments as two specialist photographers with different skills. NIRCam is a portrait photographer that captures shorter infrared wavelengths, 0.6 to 5 micrometers. Its job is to take sharp or clear images of star populations. This allows it to distinguish individual stars in Andromeda, even within clusters that Hubble could only see as blurry spots. Because stars shine brightest in this near-infrared range. But MIRI is a different kind of specialist. It's a thermal camera. It detects longer infrared wavelengths, 5 to 28.5 micrometers. This range is ideal for detecting the faint heat emitted by colder objects like dust particles and aging stars. Thanks to MIRI, we can see the glow of cold dust disks where new solar systems are forming. But this sensitivity comes at a price. To prevent MIRI's own heat from interfering with the faint signals it observes, it must be cooled to just 7 degrees above absolute zero, or minus 266 degrees Celsius. When these two views are combined, a complete anatomical map of a galaxy emerges. NeoCam tells us, where are the stars, while MIRI answers the question, where is the raw material to form new stars? Without this dual vision, we could never have pieced together the full picture of the distorted dust rings in Andromeda's heart, MIRI data, and the hidden star nurseries in its spiral arms, NeoCam data, because one shows the bones and the other shows the tissue that connects those bones. Webb's third and perhaps most powerful mechanism is spectroscopy, the art of reading the universe's chemical codes. This allows the telescope not only to say, there's something there, but to tell us what that thing is made of, how hot it is, and how fast it's moving. We can compare this process to a barcode scanner at a supermarket checkout. Every product has a unique barcode that reveals its identity and price. In the universe, every chemical element and molecule also has its own spectral barcode. When light from a star or gas cloud enters a special instrument on the telescope called a spectrograph, it is separated into its colors, as if it passed through a prism. But this rainbow is not smooth. It has bright lines, emission, or dark lines, absorption, on it. The pattern of these lines is a precise fingerprint of the elements in the gas the light passed through, sakshi, like carbon, oxygen, and iron. Hubble also had spectrographs, but Webb's sensitivity and resolution are revolutionary. Webb can take the light from a single star cluster in Andromeda and determine its chemical composition and age with incredible precision. It can measure the temperature of gas clouds with the precision of fractions of a degree. It can even tell if an object is moving toward or away from us, and how fast from the tiny shifts in these spectral lines, the Doppler effect. This is the mechanism by which we discovered that the gas filaments flowing rapidly toward the center of Andromeda were moving faster than gravity could explain. Because their spectral barcodes told us not only of their existence, but also of their panicked motion. This is the basic arsenal of Webb, composed of these three mechanisms: infrared eyes that see through dust, a dual camera system that maps stars and dust separately, and a spectral barcode reader that reveals the chemical secrets of objects. When these three tools combine, we can study a distant galaxy like Andromeda as if a biologist were examining a cell under a microscope. But for all these instruments to work, the telescope itself must be an engineering marvel. Because operating these sensitive eyes perfectly from millions of kilometers away, protecting them from the sun's scorching radiation in the freezing cold of space, is perhaps an even greater challenge than the science itself. How does the physical structure behind these tools, that giant golden mirror and the tennis court-sized sun shield, work? Because keeping this giant eye open in space is farm in itself, an epic engineering achievement. And at the heart of this achievement lies the telescope's iconic symbol, the massive golden mirror. This mirror is the heart of Webb's light-collecting power. We can compare a telescope's mirror to a bucket used to collect rainwater. The wider your bucket, trolls, the more raindrops you collect. Similarly, the larger a telescope's mirror, the more of those precious photons, or particles of light, it collects from the faintest and most distant corners of the universe. Webb's primary mirror is 6.5 meters in diameter. This is almost 3 times wider than Hubble's 2.4 meter mirror. This size difference means a massive increase in light collecting area. Webb can collect about 6.25 times more light than Hubble. Therefore, Webb can see objects in hours, with much greater clarity, that Hubble could barely see with weeks of exposure. But it was impossible to send this massive mirror into space in a single piece. So, engineers developed a foldable design consisting of 18 hexagonal beryllium segments. Each segment weighs about 40 kilograms and is coated with a layer of gold only a few atoms thick. This gold coating is not an aesthetic choice. Gold has an extraordinary ability to reflect infrared light. It reflects more than 99% of the incoming infrared photons, ensuring almost no light is lost. That's why Webb's eyes are not only large, but also incredibly efficient. Every single photon from Andromeda is as precious as a treasure. And this golden mirror ensures that not a single piece of that treasure is lost. But for this massive and sensitive mirror to work, the telescope itself must remain extremely cold. This is where another of Webb's engineering marvels comes into play: the sun shield. This shield is about the size of a tennis court and is like a giant 5-layered umbrella that protects the telescope's instruments from the heat of the sun, Earth, Dasai, and Moon. Without this shield, the telescope's own heat would completely drown out the faint infrared signals it's trying to observe. Just like it's impossible to see the stars in a bright city. Each layer of the shield is made of a special material called capton and is thinner than a human hair. But despite this thinness, it is incredibly durable. While the temperature of the outermost layer facing the sun reaches about 110 degrees Celsius, the telescope and instruments behind the innermost layer are kept at a freezing minus 233 degrees Celsius. This is a temperature difference of about 343 degrees, a hasit, and this incredible insulation is achieved thanks to the vacuum gaps between the layers. Each layer reflects the heat from the one below it, back into space. This passive cooling system is so effective that, except for the most sensitive instruments like MIRI, the rest of the telescope does not need a complex coolant system. This sun shield is the primary reason Webb can measure temperature changes in the heart of Andromeda with the precision of fractions of a degree. Because only by completely eliminating its own heat can it hear the faintest thermal whispers of the universe. And finally, there is an invisible nervous system that collects, processes, and sends all this data to Earth, the Integrated Science Instrument Module, ISIM. This module is the brain that houses Webb's 4 main scientific instruments, including NIRCam, MIRI, and the spectrographs. This isn't just a box. It's a complex network of electronics and software that ensures every instrument, whilst every mirror, and every sensor works in perfect harmony. When it takes an image of Andromeda, the process is as follows. Light reflected from the 18 mirror segments is focused onto a secondary mirror. This secondary mirror directs the light to the instruments inside the ISIM. Let's say a spectroscopy observation is being made. The light passes through a slit inside the chosen instrument. Chalked is separated into its colors by a prism or a diffraction grating, and finally falls onto the detectors. These detectors are like digital cameras made of millions of pixels that count every incoming photon. This raw data is generated at an incredible rate of about 458 gigabits per second. But it's impossible to send all this data to Earth The processors inside the ISIM pre-process the data, compress it, and transfer it to the telescope's communication system to be sent to Earth. Since Hubble was in low Earth orbit, it could send data directly and quickly. But Webb orbits at the L, 2.1.5 million kilometers from Earth. Therefore, the data is sent via the Deep Space Network, and this process can take hours. Without this complex nervous system, all the valuable data Webb collected would have remained a lost whisper in the depths of space. The golden mirror, the tennis court-sized sunshield, LUCT, and the complex nervous system that manages all the instruments. These three fundamental structures are the mechanisms that allow Webb to see the secrets of the universe. They are the technological marvels that show us Andromeda's distorted rings, hidden star nurseries, and rapidly flowing gas. We now know how the telescope works, how its eyes see. We understand the technical details. But what's truly exciting is what this technology tells us. Because Webb's data tells a story not just about Andromeda, but about the fate of all galaxies, about our own fate. And the most dramatic part of this story is the inevitable meeting of two giants, the ultimate collision of Andromeda and the Milky Way. Now, it's time to witness the most crucial moments of this apocalyptic scenario through the eyes of the telescope. Because the future Webb shows us is a symphony of both terrifying and magnificent destruction and rebirth. And the first notes of this symphony have already begun to, and those notes whispered the beginning of an apocalypse. The technical details are over. The calm analyses have ended. Because now, we have reached the climax of this cosmic saga. Now, it is time to witness the inevitable future that the telescope has shown us. A future that is both terrifying and awe-inspiring. The tempo is increasing. Breaths are held. Because what you are about to see is not a simple meeting of two galaxies. This is a symphony of destruction and rebirth. This is the final waltz of the Milky Way and Andromeda. And we are right in the middle of that dance floor. Here are the most epic, most shattering acts of this cosmic opera. The first act, silent, but the most terrifying. Because the collision will not happen in 4 billion years. The collision has already begun. This is not a theory. This is an observational fact. Confirmed in 2020, scientists discovered that the massive gas envelope surrounding Andromeda, minus its halo, extends more than 1.3 million light-years in every direction from the center. Our own galaxy, the Milky Way, has a halo of almost the same size, and the distance between the two galaxies is only 2.5 million light-years. This is simple math. The invisible outer layers of the two giants are touching right now. They are even intermingling. This contact is estimated to have been going on for 1 billion years. This is not the future. This is the present. Right now, as you read this text, the outermost layers of our galaxy are interacting with Andromeda's ghostly gas. This is like the first contact between the vanguard units of two armies, silent, unseen, but irreversible. This discovery fundamentally changed our perception of the collision. We are not waiting for an approaching catastrophe. We are living through the first act of a catastrophe that has already begun. This is the first time in history that we are witnessing the beginning of a merger of two giant galaxies from the inside. For the scientific world, this was a paradigm shift. The question is no longer, when will they collide? The question is, when will this silent contact turn into an all-out war? And that war is coming. The second act. The sky will ignite. this will be the greatest visual spectacle history will ever witness. In about 2 billion years, Andromeda will no longer be a faint smudge in the night sky. It will cover the entire sky as a breathtaking kassetsit, massive spiral, stretching from horizon to horizon. But this will not be a peaceful sight, because in about 3.75 billion years, the first close pass will occur. The disks of the two galaxies will begin to pass through each other. Due to the vast spaces between stars, individual stars will most likely not collide. They will be like ghosts passing through each other without touching. But the gas clouds, they will collide. And this collision will trigger the greatest starbirth festival the universe has ever seen. Millions, nowadays perhaps hundreds of millions of new, bright blue stars will be born. The night sky will be illuminated by the intense light of these newborn stars. It will be so bright that shadows will form even at night. This will be an explosion of fertility that neither the Milky Way nor Andromeda has ever experienced in their billions of years of history. But this is a moment of creation as much as it is a moment of destruction. Because, after this first pass, the galaxies will separate again. But they will never escape the chains of gravity. They will orbit each other, pulled toward a second, even more violent collision. And when that moment comes, everything we know will end. The third act, destruction, absolute destruction, and the birth of Andromeda. After the second collision, there will be no spiral structures left. Billions of years of elegant arms will be torn apart by gravitational chaos. Stars will be scattered in all directions like stones flung from a sling. In about 7 billion years, the merger will be complete. The two galaxies will transform into a massive elliptical galaxy with no recognizable structure. Us astronomers have already given this new galaxy a name, Andromeda. Our Sun will probably not be destroyed in this process, but its orbit will change radically. Simulations show that we will be flung much farther from the new galactic center, perhaps 50,000 light-years away. The probability of our solar system being completely ejected from the new galaxy is about 12%. This means an eternal exile, to be thrown into the pitch-black darkness and absolute loneliness of intergalactic space, along with billions of other stars. All the constellations we know in the sky will disappear. Our galactic center will no longer be in the direction of Sagittarius. Our home will become unrecognizable. This is not just the death of a galaxy, but the complete destruction of our cosmic identity. Our address, the order that has lasted for billions of years. This is the greatest story of homelessness imaginable. The fourth act, the war of the gods. But the stars, thus the gas, the planets, they are just pawns in this war. This war has its true kings, those supermassive black holes lurking in the heart of each galaxy. And now, they meet. This will be the most violent, most incredible moment of the entire saga. Our galaxy's 4 million solar mass black hole will enter a death spiral with Andromeda's 140 million solar mass monster. For millions of years, they will orbit each other, slowly, then faster, and finally, they will collide with a violence that rips through time and space itself. This will not be an explosion. This will be a vibration of the fabric of space-time itself. This collision will release a gravitational wave burst so powerful that it will ripple through the fabric of the universe like a shockwave. The greatest energy release imaginable. In that single moment, this merger will release more energy than all the stars in the observable universe combined. This will be the greatest act of violence the universe has ever seen. Civilizations thousands, tens of thousands of galaxies away. If they exist, we'll detect this indescribable scream coming from the heart of the universe with their instruments. And from this apocalypse, a new monster will be born. The two giants will merge to form a single, even larger, even more insatiable black hole of about 144 million solar masses. And the final act, the ultimate loneliness, the appetite of this newborn monster will not end. Its hunt will continue. The third largest member of our local group, the Triangulum Galaxy, will not escape this fate. It too will likely be swallowed by Andromeda. Over the next 150 billion years, all the surviving dwarf galaxies in the local group will be captured one by the gravity of this new giant and will dissolve within it. More than 50 galaxies in total will be destroyed. And what will remain is the ultimate fate of our cosmic neighborhood. A single, massive, monolithic island of light, surrounded by a bottomless void that is constantly expanding with the universe. This is the end of the story of the local group. What was once a bustling community of galaxies will become a silent kingdom ruled by a single giant. A collision that has begun. A sky on fire. A home torn apart. The ultimate war of two gods. And finally, an absolute reign. This is the future Webb has shown us. But what if this entire scenario, this terrifying symphony, is far more violent, far more chaotic than we expect? Because there is something we have forgotten in all these future predictions. The fact that the 140 million solar mass monster in the heart of Andromeda is waking up right now, before our very eyes. And this awakening changes all the rules it was changing. And this awakening could instantly invalidate all our scenarios for the future. Because this was a variable we hadn't included in the equation. The awakening of the monster. This means the future could be far more violent, far more chaotic than we predicted. Because the data patiently collected by the Chandra X-ray Observatory for over 20 years has confirmed a chilling fact. Andromeda's central black hole, M31, has been waking from its slumber since 2006. It has entered a new, much more active phase. Massive flares occurring at irregular intervals show that this monster is feeding more often, devouring the surrounding matter with a greater appetite, and relentlessly bombarding its surroundings with high-energy radiation. This is like a dragon waking from a deep sleep, breathing its first fiery breath, and this upends the entire collision scenario. Because, in 4 billion years, we will not just be colliding with a calm giant, but with a fully operational, active monster. This means the collision will occur with unpredictable violence, with uncontrolled energy. The physics we know struggles to model this new situation. This is a journey into the unknown. But the mystery doesn't end there. Deeper, there is an even more impossible discovery. The fingerprints of ghosts, at the exact same time as these X-ray flares. The Ice Cube Observatory, buried kilometers under the ice in Antarctica, detected high-energy neutrinos. These ghost particles, which almost never interact with matter, were coming from the exact direction of Andromeda. This could not be a coincidence. It was like a fingerprint left at the scene of a crime. The existence of neutrinos whispered that the particles around the black hole were being accelerated to much higher energies than our current physical models predict. There, a physics we do not understand, cannot predict, is at work. This is not just an awakening. This is an awakening happening by rules we do not know. This was the universe's way of telling us that we do not yet fully understand its laws. For the scientific community, this meant that even the most fundamental theories had to be questioned. This data was the subject of hundreds of scientific papers, but none could provide a complete explanation. Because these ghosts carried a message that pushed the boundaries of science, a power greater, more fundamental than we know, may be awakening in the heart of Andromeda. Therefore, the future collision will not just be a merger of two galaxies, it will also be a collision of two different, perhaps incomprehensible, laws of physics, light, surrounded by a bottomless void that is constantly expanding with the universe. This is the end of the story of the local group. What was once a bustling community of galaxies will become a silent kingdom ruled by a single giant. A collision that has begun. A sky on fire. A home torn apart. The ultimate war of two gods. And finally, an absolute reign. This is the future Webb has shown us. But what if this entire scenario, this terrifying symphony, is far more violent, far more chaotic than we expect? Because there is something we have forgotten in all these future predictions. The fact that the 140 million solar mass monster in the heart of Andromeda is waking up, right now, before our very eyes. And this awakening changes all the rules it was changing. And this awakening could instantly invalidate all our scenarios for the future. Because this was a variable we hadn't included in the equation. The awakening of the monster. This means the future could be far more violent, far more chaotic than we predicted. Because the data patiently collected by the Chandra X-ray Observatory for over 20 years has confirmed a chilling fact. Andromeda's central black hole, M31, has been waking from its slumber since 2006. It has entered a new, much more active phase. Massive flares occurring at irregular intervals show that this monster is feeding more often, devouring the surrounding matter with a greater appetite, and relentlessly bombarding its surroundings with high-energy radiation. This is like a dragon waking from a deep sleep, breathing its first fiery breath, and this upends the entire collision scenario. Because, in 4 billion years, we will not just be colliding with a calm giant, but with a fully operational, active monster. This means the collision will occur with unpredictable violence, with uncontrolled energy. The physics we know struggles to model this new situation. This is a journey into the unknown. But the mystery doesn't end there. Deeper, there is an even more impossible discovery. The fingerprints of ghosts. At the exact same time as these X-ray flares, the Ice Cube Observatory, buried kilometers under the ice in Antarctica, detected high-energy neutrinos. These ghost particles, which almost never interact with matter, were coming from the exact direction of Andromeda. This could not be a coincidence. It was like a fingerprint left at the scene of a crime. The existence of neutrinos whispered that the particles around the black hole were being accelerated to much higher energies than our current physical models predict. There, a physics we do not understand, cannot predict, is at work. This is not just an awakening. This is an awakening happening by rules we do not know. This was the universe's way of telling us that we do not yet fully understand its laws. For the scientific community, this meant that even the most fundamental theories had to be questioned. This data was the subject of hundreds of scientific papers, but none could provide a complete explanation. Because these ghosts carried a message that pushed the boundaries of science, a power greater, more fundamental than we know. Maybe awakening in the heart of Andromeda. Therefore, the future collision will not just be a merger of two galaxies, it will also be a collision of two different, perhaps incomprehensible, laws of physics, and Webb threw new fuel on this fire of uncertainty. What it saw deepened this chaos even further. Webb's sharp infrared eyes revealed unprecedented details in the normally invisible dust rings beneath Andromeda's satellites. Traces of complex organic molecules, asymmetrical and clumpy clusters, irregular temperature distributions. They all whispered the same unsettling story. An invisible and massive force is stirring the core of Andromeda. This is like the sign of volcanic activity beneath the surface of a calm lake. This discovery becomes even more significant when combined with the mystery of the Great Plain of Andromeda. This impossible arrangement of the satellites and this internal chaos at the core may be linked. See, perhaps the invisible hand that strings these satellites like a necklace is also the force that is stirring the core, waking the black hole, and creating those ghost neutrinos. This is a mystery too big to be explained by galactic mergers alone. This is a chain of findings that shakes our most fundamental assumptions about the nature of dark matter, the basic mechanisms of galaxy evolution, and perhaps even gravity itself. Webb showed us not only Andromeda, but also how deep our own ignorance is. Science is not a body of answers, but a growing ocean of questions. And Webb has poured new, massive rivers into this ocean. All of this brings us to the ultimate and most disturbing question. Galaxies breathe, just like living things, galactic winds. Fueled by bursts of star formation and black hole activity, regulate their own growth by blowing gas out of the galaxy. Andromeda's winds have been revealed with such clarity for the first time thanks to Chandra's X-ray data, and now Webb's infrared observations. And these winds seem to be turning into a storm with the increasing activity of the waking black hole. Andromeda's breath is becoming sharper. This is not a simple metaphor. This could mean that the galaxy's internal balance is changing, that its self-regulation mechanism is spinning out of control. The waking black hole is not only heating and stirring the galaxy, but it may also be suffocating future star formation by blasting its vital gas into space. This could mean the galaxy has entered a process of self-destruction, and we are watching this process from the front row. This changes the merger scenario completely, because in 4 billion years, we may not just be colliding with an active monster, but with a dying, struggling galaxy. And these death throes could make the merger unimaginably chaotic and unpredictable. When we study Andromeda, we are not just looking at a neighboring galaxy, we are looking at a model for the universe itself, a rehearsal for our own future, a waking monster. An awakening that does not follow our laws of physics, an impossible satellite arrangement that may be linked to this awakening, and a galaxy that may have entered a process of self-destruction. This is the picture Webb presents to us at its climax. This is far beyond a simple collision story. This is a story of unknown forces, incomprehensible laws, and cosmic death throes. This flood of discoveries, flowing at maximum speed, took our breath away. It shocked us. But now it is time to stop and think. Time to slow down and ask what all this dizzying data, these epic scenarios, mean for us, for the conscious beings on this small, blue planet. What is humanity's place in the midst of this cosmic drama? What does this inevitable future tell us about our existence? Because in the midst of this massive merger, this violent awakening, a strange paradox comes to mind, and this paradox will take us from the greatest mystery of the universe to the deepest secret of life, sleep. And this secret holds an evolutionary power as fundamental and mysterious as the collision of galaxies. And this awakening was changing all the rules. The fast-flowing stream of discoveries took our breath away. It shocked us. But now it is time to stop and think. Time to pause amidst the epic scenarios, the record-breaking numbers, and the dizzying speed, to confront the most fundamental question. What is our place in this cosmic drama? What do we, these small, fragile, transient beings, mean in this massive, violent, billion-year-long story? The James Webb Space Telescope didn't just show us distant galaxies. It held up a giant mirror, reflecting the deepest, most unsettling, and most beautiful paradoxes of our existence. Now is the time to look into that mirror and understand ourselves. Our place in this grand symphony of the universe. Here is the first and most overwhelming paradox. The paradox of scale. On one hand, there is a galaxy 2.5 million light-years away, containing 1 trillion stars, with a diameter of 220,000 light-years. At its center, a black hole of 140 million solar masses lurks, with an event horizon wider than the orbit of Mars. These numbers are too large for the human mind to truly grasp. They represent an order of magnitude beyond our reality. On the other hand, there is us, biological machines, averaging 1.7 meters in height, living for at most 80 to 90 years, stuck to the surface of a tiny planet. How can this be? How can the unimaginable vastness of the universe and our incredible smallness be part of the same reality? The tragic truth of this comparison is our physical limitation. We will never go to Andromeda. Even with our fastest spacecraft, it would take tens of billions of years to get there. We are prisoners of this solar system, this small neighborhood. It is physically impossible for us to touch those magnificent landscapes, those massive worlds. We are like children born in a house by the sea, but who can never set sail on that ocean. We can only watch from a distance. But that word "but" changes everything, because even though we can't physically go there, our minds can. That roughly 1.5 kilogram organ inside our 1.7 meter bodies. Our brain, can build a bridge that spans 2.5 million light years. We can measure it. We can calculate its weight. We can model its speed, its chemistry, its future. Our bodies may be a prison, but our consciousness is as boundless as the universe itself. You might too, right now, while looking at this small screen, are actually taking a journey with your mind millions of light years away. You are part of a billion-year-old consciousness trying to solve the secrets of that massive galaxy. Our power lies not in our physical size, but in our ability to understand. And this is the greatest miracle the universe has bestowed upon us. We are the eyes, ears, and brains the universe created to understand itself. And this leads us to a second, even deeper paradox, the paradox of time. On one hand, there is a universe that is 13.8 billion years old. There are galactic mergers that last for billions of years, stars that will shine for tens of billions of years, and an inevitable collision that will occur in 4 billion years. Should time here flows on a geological and cosmological scale, completely outside our perception. It is almost eternity. On the other hand, there is us again. An average lifespan of 80 years, gone in the blink of an eye. All of human history, from the Egyptian pyramids to today, is just a few seconds on the cosmic calendar. We are but a momentary flash, a transient wave in this vast ocean of time. The tragic truth of this situation is our mortality. We will not be able to witness that great collision. We will not be here when our sun becomes a red giant. It is uncertain whether our species will even exist in that distant future. We exist to see only a single frame of a billion-year-long movie. This could be a source of sadness. It might make us think about how meaningless and temporary our existence is. But that magical but appears once again. Because, yes, we exist for only a moment. But we exist at exactly the right moment. In the first moment in human history where we have the technology and knowledge to understand these great secrets of the universe. Just a few centuries after Galileo. We are a generation that can see the beginning of the universe, that can calculate that galaxies will collide. We may not be able to see that 4 billion year collision, but we are the first beings to know that it will happen. We are living in that precious, chart's unique moment when we are unlocking the secrets of the past and the future. Your short life is not a meaningless dot. It is at the very center of one of the most important moments when the universe understands its own story. You are a part of this moment, but you are a witness to that moment of understanding that comes after billions of years of silence. And that is more valuable than the longest life. Because what matters is not how long we live, but how deeply we can look in that short life. And this gaze brings us to the third and most humbling paradox, the paradox of knowledge. On one hand, there is the incredible wealth of data that the James Webb Telescope has provided us. We now know the mass of Andromeda, the weight of its black hole, its chemical composition, the motion of its satellites. Thanks to billion-dollar engineering marvels, we know more about the universe than ever before. Our knowledge has grown exponentially in the last century. We might feel like the masters of the universe. On the other hand, there is the vast ocean of ignorance revealed by each new discovery. Webb didn't just give us answers, it gave us hundreds of new questions we didn't even know to ask before. How did that impossible satellite plane form? What is accelerating the gas more than gravity? What is the unknown physics behind those ghost neutrinos? What is dark matter really? As the boundary of our knowledge expands, we see more clearly how vast the darkness beyond that boundary, our ignorance, is. The tragic truth of this situation is that we may never know everything. The universe may be fundamentally unknowable, beyond the grasp of our minds. Perhaps no matter how much we learn, we will always be faced with a greater mystery. This might feel like a failure, but that but once again guides us. Because the beauty of science and human curiosity lies not in finding the answers, but in asking the questions. The unknown is not an enemy, but an invitation. It is an adventure that calls us deeper, further. A universe where answers run out would be a boring, dead universe. But a universe full of mysteries is a living, breathing place waiting to be explored. Isn't your life like that too? You encounter new questions every day, and what makes you grow, what develops you, is not so much the answers you find, but the questions you dare to ask. Because to be human does not mean to know everything. To be human is to admit what you don't know and yet continue to search. We are not beings with answers. We are beings who search for answers, And this search is the most fundamental meaning of our existence: scale, time, and knowledge. These three great paradoxes are our own reflection that we see in the mirror Andromeda holds up to us, but even these reflections are just the visible face of the story. Because within this cosmic loneliness, this overwhelming vastness, and this infinite mystery, there may be another truth that we struggle to notice. Perhaps our connection with the universe is not limited to just understanding. Perhaps we are not just witnesses. What if there is a deeper, more fundamental connection? Another whisper echoing in the cosmos that we struggle to hear. And that whisper brings us to perhaps the most surprising paradox, the most fundamental contradiction at the heart of our existence, the paradox of destruction and creation. On one hand, there is the absolute annihilation that the collision with Andromeda will bring, the tearing apart of billions of years of elegant spiral arms, stars being dragged into chaos, our solar system perhaps being sent into an eternal exile. This is the end of everything we know, our cosmic home, our identity. This is a symphony of apocalypse. Literally, the end of a world. On the other hand, there is the incredible creation that will be born from the very heart of this destruction. The colliding gas clouds will trigger one of the greatest starbirth festivals the universe has ever seen. Millions, perhaps hundreds of millions, of new, bright blue stars will be born from the ashes of this chaos. This is a moment of death as much as it is a moment of birth. The tragic truth of this situation is that we will not be able to see that rebirth. Our world, our order, will not exist under the light of those new stars. We are the generations that witness the destruction of our own universe, but will never see the creation of the new one. This is a farewell. But that word "but" reminds us of the most fundamental law of the universe. Nothing is ever truly destroyed. It is only transformed. On a cosmic scale, death is the beginning of a new form of life. The atoms of our galaxy will become the building blocks of the new stars and perhaps planets that will be born in the future. We are the seeds of the future. Don't you experience this cycle every day in your own life? A friendship that ends, a chapter at work that closes, a city left behind. Every end opens the door to a new beginning, a new possibility. You, just like galaxies, are a being that is constantly destroying and recreating yourself in your own small universe. And therefore, the end that Andromeda brings is not an ending, but a transformation. And this is the most brutal, yet most hopeful truth of the universe. And this transformation leads us to another, more personal paradox, the paradox of loneliness and togetherness. On one hand, there is the unimaginable void and silence of the universe. The 2.5 million light-year distance between the two galaxies is a wall of loneliness that our species can never overcome, our ultimate fate. After all other galaxies in the local group are swallowed, is to become a single giant island surrounded by an ever-expanding void. This is absolute cosmic isolation. The possibility of our solar system being ejected from the galaxy could condemn us to pitch-black darkness and an eternal exile with billions of other stars. This is the deepest loneliness imaginable. The tragic truth of this situation is how vast the universe is and how alone we are. We are like a colony of ants living on a grain of sand. We are aware of the ocean's existence but can never reach it. But that but whispers to us that this loneliness may be an illusion. Because The fundamental force that started this whole story, that pulls galaxies together, that keeps stars in orbit, gravity, is not a force of separation, but of union. Andromeda is not just coming toward us, we are also going toward it. This is not a collision of two strangers, but the ultimate meeting of two families that have been journeying toward each other for billions of years. This is an embrace. Therefore, the most fundamental law of the universe is not isolation, but connection. You are a part of this connection. The atoms that make up your body right now were forged in the hearts of stars that exploded billions of years ago. You are, quite literally, made of stardust. The air you breathe, the water you drink, connects you to every living thing on this planet with invisible bonds. Even in the moments when you feel lonely, you are never truly alone. You are an inseparable whole with the universe itself, with its past and its future. And this is our most fundamental consolation, giving us strength even in the moment of deepest loneliness. And all these thoughts bring us to the strangest and most unexpected paradox, the paradox of survival. On one hand, there is a cosmos that merges, collides, and becomes increasingly loud and violent to survive and evolve. Galaxies devour each other to form larger, more stable structures. The universe's survival strategy is based on maximum energy, maximum interaction, and maximum unification. On the other hand, there is the life on this small planet, which has learned to do the exact opposite to ensure its own survival, to shut down, to become vulnerable, to sleep in a world full of predators for millions of years. How can this be? While the universe's greatest survival strategy is violent union, how can our most basic survival strategy be a quiet and vulnerable retreat? The tragic truth of this situation is how fragile we are. We have almost no power against cosmic events. An asteroid, offhole, a supernova explosion, the aging of our own star, all could end our existence in an instant. We are like a tiny raft on a stormy ocean. But that shows us that this fragility can also be our greatest strength. Because sleep is not just a state of rest. It is an active process where consciousness rebuilds itself. Memories are consolidated, and the body is repaired. This retreat is to come back stronger. Perhaps this is the lesson that life will teach the universe. Growth does not always have to be outward, loud. Sometimes the greatest strength lies in silence, in turning inward, and in restructuring oneself. You, too, when you fall asleep after a hard day, are actually applying this basic survival strategy. You isolate yourself from the world. You become vulnerable, but you do this to wake up stronger, more renewed the next day. You are part of life's silent resistance against the universe's violent law of unification. And this is one of the most mysterious and profound aspects of being human. We are coming to the end of our long journey to Andromeda. It did not just show us our future, it showed us who we are. It taught us that we are both insignificant and priceless. It reminded us that we are both temporary and a part of eternity. It made us feel both alone and deeply connected to the universe. We now know that that distant spot of light is not just a galaxy. It is our cosmic mirror. This journey, beyond telescopes and numbers, has turned into an inner exploration where we confront the most fundamental questions of our existence. The cold data of science has touched our warmest, cutsy, most personal feelings and thoughts. The story does not end here, but our journey in this chapter does. And what remains? In the light of all this knowledge, is a single question we must ask ourselves as we look into that vast, silent void. So because this cosmic story was from the very beginning, our story. In this journey, we saw the future of the universe. But there's something I didn't tell you. What if it's also possible to go to the past? The singularities at the center of black holes and Einstein's theory of relativity may be opening a door in the fabric of time. In our next journey, we will examine the theoretical plans for a time machine. Is it possible to change the past? Are you ready?